the reverse process. We are given an organic name and we need to draw it out. So when you're given an organic molecule name, the first thing is find your table P information. So I see BUT, I see bute. That is something that is on table P. And when I go and look bute on table P, I know N equals 4. So I'm going to draw 4 carbons. Now my table Q, okay, I see An, so that's from my table Q. It means that this is an alkane, so all my carbon-to-carbon bonds are single. So I'm going to add those in. Now, when I take a look at this name, I see that it ends in OL. So that is very important. When I see that it ends in an OL, that tells me that this is an alcohol, and that means that I need to put an OH on the parent chain. The 1 right here, okay, it tells me the location. So as soon as you see the locations, just number your carbons left to right. So carbon 1, 2, 3, 4. And according to this, I need to put the OH on carbon 1. So I'm going to put it like this. So remember, the oxygen, it has to be shown bond to the carbon. So it's going to look like this. It's understand to be OH. Okay? So now at this point, I have placed everything in this organic name in the structure. The last step is to make sure every carbon has its 4 bonds, and we do this by adding in hydrogen. So carbon 1 has 2 bonds, so it needs 2 hydrogens to get to 4 bonds. Carbon 2, it only has 2 bonds, so we have to add 2 hydrogens to it. Carbon 3 only has its 2 bonds, so we add 2 hydrogens to it. And carbon 4, it has only 1 bond, so we have to add 3 hydrogens to it. Now we're going to translate this into the condensed structural formula. So carbon 1, okay, it has 2 hydrogens directly attached to it, so we put CH2. Then we have the alcohol, which is OH. So we put that in the condensed formula as OH. Carbon 2, okay, it has 2 hydrogens attached to it. Carbon 3 has 2 hydrogens attached to it. And carbon 4 has 3 hydrogens attached to it. And when I went over table R and things to look for in this condensed formula, you can see that HOH sequence in the condensed formula to help you recognize this is definitely an alcohol. Okay, so let's take a look at the next example. So here we go. It says 1,4-butanediol. So I take a look and I see bute. So that is my table P prefix, and when I go find bute on there, N equals 4. So I'm going to draw my 4 carbons. When I take a look here, it ends in AN, so that tells me that this is an alkane, so single bonds. So I'm going to attach the carbons in the parent chain with just single bonds. Now I see here, I see that OL. So that means that this is an alcohol. So that means I have to add OHs to the carbon chain. But I also see here that di. So that means that there I have to add 2 OHs to the PC. And I see the number locations. These are the locations of each of those 2 OHs. So immediately I'm just going to number left to right. 1, 2, 3, 4. Okay, my OL, I'm going to start there. My first OH is on carbon 1. So here's carbon 1. I'm going to put my OH there. And the second alcohol OH is on what I labeled as carbon 4 right here. I put everything in the name in the structure. Now I need to make sure every hydrogen has the correct number of bonds, and I do bond fulfillment with H's. So carbon 1 has 2 bonds, so it needs 2 H's added to it. Carbon 2 already has 2 bonds, so it needs 2 H's added to it. Carbon 3 has 2 bonds, so it needs 2 H's added to it. And carbon 4 has 2 bonds, so it also needs 2 H's added to it to do the condensed formula. So we have carbon 1, it has its 2 H's, so H2, and then the alcohol, the hydroxyl, OH. Carbon 2 and 3, so carbon 2 only has 2 H's attached to it. Carbon 3 has 2 H's attached to it. And carbon 4, it has 2 H's attached to it plus the hydroxyl group, the OH. And in this sequence, I can see HOH and I can see another HOH sequence. So knowing that this alcohol is a diol because there's 2 OH's attached to it.